Welcome, viewers. So, after a very long time, this is going to be my second video of my enzyme kinetics. Part one, I have released or published around 2 years before, and I have seen comments of most of these students who were actually looking for the part two. So, first of all, I want to apologize for the viewers because I made them wait for long years. But in the meanwhile, I was really busy with tutoring, and in this time span, I have made careers of most of my students who are from US, Canada, Australia, Singapore, and so on. So let's begin. It is enzyme kinetics part two. Now, the first question is about for the enzyme catalyzed reaction, enzyme plus substrate gives out enzyme substrate complex, which will give enzyme and the product, right? So what equation defines the rate at which the ES is formed, right? And then they have given the meaning of most of the things like ET means total enzyme concentration. This means substrate concentration. Also, K1 is a rate constant for the formation of ES, and K negative 1 is a reverse rate constant, right? So first of all, my suggestion for you all is to write the equation separately, which is given in the question, and then just place the rate constants at their proper places, right? It is K negative 1, right? Okay. Now, the persons who have a little bit understanding of this equation, they can easily say that, oh, I think it is ES and not ESS. Yes. Okay. Yeah. Enzyme substrate, complex or the transition stream, right? So the people who have little understanding of the rate constant and the substrate and the product, they can easily say that because this particular fellow or these particular rate constant is not given in the question, right? So you need to be concerned with only these two things, firstly. Second is that out of the K1 and K negative 1, actually K1 is actually the K1 means for forward, right? K1 means for forward reaction, and forward means it will be towards the production of ES complex, which is given in the question. Clear? Now, basically, we can say that we can then opt out all the options which have K negative 1 in them, right? This is just one way of solving the or picking the right option, right? Out of the four options. So basically, you can say that B cannot be true and C cannot be true, right? Now, among A and D, these two options can actually follow the K1 and something, right? Now, let's suppose in the simple scenario, what we can say that the rate of formation of ES will be directly proportional to the concentration of S or the substrate concentration, right? Or we can say that ES, right? Sorry. We can say that the production of ES will be directly proportional to the K1 will be directly proportional to the concentration of ES. This is one thing. But what we know, if the concentration of the enzyme and total concentration of the enzyme is given, it means that, that in a reaction sample, if this is a test tube, and in the test tube, you have placed these circles are the enzymes, right? These circles are the enzymes. Every red circle represents a molecule of enzyme, and every small circle represents a molecule of substrate, right? Okay. This is substrate and this is enzyme. So the point is that the total concentration of the enzyme means ET. It's a different value or the maximum value of the enzyme. But the concentration of the enzyme, which is bound with substrate, right? This is different. Got my point or not? Total concentration of the enzyme. Let's say we have taken 100 molar of enzyme at the start of the reaction, right? But when this reaction happens, it is not necessary that the total enzyme gets occupied with substrate, right? So you can see that the concentration of the ES, right, or the molecule of the S, which combines with the enzyme to get ES complex, will be less than the total substrate total concentration of the enzyme. In short, we can say that ET will be the total enzyme concentration and ES will be the amount of the enzyme which is bound with substrate, right? So this particular difference, if multiplied by S, then it can give rise to the value of the ES formation, right? Or the rate of the ES formation. Rate of ES formation. You got my point or not? Right? And this is why A is the correct answer, right? Once again, in the total enzyme concentration, the ET will be different, but out of the total enzyme, only few molecule of enzyme will get chance to combine with substrate, right? Like this, like 1, 2, 3, 4, 5, 6, 7, 8, and 9. I have taken only 9 units of enzyme into the reaction vial, but out of the 9, only 4 gets occupied with substrate, right? So only those amount of enzyme, right, which is occupied with substrate, ES minus total concentration of the enzyme, right? So basically, when you do a subtraction of this value and then multiply with the concentration of the S, you will get the rate of formation of the expression. It is a very simple question of mathematics. Coming towards the second question, which is about the Line-Weaver-Burke plot, right? So how can the Michaelis-Menten constant or Km be derived from this Line-Weaver-Burke plot, right? Now, for this kind of question, I would suggest you to go over my video of the enzyme kinetics, right? Part 1 and part 2. And when you go over the entire videos, then you will got to know that in one of the videos, I discussed about the this value, I mean the Line-Weaver value. So basically, the if you recall, the Michaelis-Menten equation was V naught is equal V max into S over Km plus S, right? Why I am defining this? Because the students will be working how to derive the Line-Weaver plot from the Michaelis-Menten kinetics. It is just that you need to do reciprocal on both sides, right? So reciprocal on both sides means 1 upon, right? Means the thing which is on the left will be 1 upon, and the thing which will be right will become reverse, right? So basically, we can say that it is V naught upon 1 initially, and now it is 1 upon V naught after doing the reciprocal on the left hand. Now, when we do the reciprocal on the right hand, it will be Km plus S over V max into S, right? Okay. Now, the left thing will not be changed, but you can do sudden change into the right thing, just look at this numerator and denominator and tell me that whether you can write the above equation like this or not. V max into S plus S over V max into S. Can we write this equation like this? Exactly, we can write like this because in the numerator, the two things are added. In the denominator, the two things are with the multiples of each other. That means this particular multiple is dividing Km and this particular multiple is dividing S, both, right? So we can write this equation like this. Now, basically, when we do this, we can see that S and S will be crossed out from this equation. So into the next line, what it will be? It would be 1 upon V naught is equal Km upon V max times 1 upon S, right? We can split this like this or not, right? We can split like this. Why I'm splitting it like this? Just I'm going to explain into the next slide, right? So this particular thing is known as Line-Weaver-Burke equation. which you derive just knowing the Michaelis mental equation. Okay. Now, basically, this equation, after derivation, it comes to know that it is a particular sequence of y is equal mx plus c, right? And this is nothing but a straight line equation. Straight line equation, right? So you have derived, you have changed your mechanistic mental equation into a certain equation through which you can draw the straight line, just like this, given here, right? Now, when you know these things, then what you need to know extra about this equation is that this particular value or n, right? N basically represents the slope of the line. Or we can write here that this particular slope is going to be n, and the value of n, if you look at this, it will be equal to km over dx, right? The value of the n will be equal to the km upon dx, right? And n is the slope, 1. Second thing is that what is x and what is c, right? So basically this x is going to be your x-intercept. It is going to be your x-intercept, and c is going to be your y-intercept, right? X is going to be your x-intercept, and this is going to be your y-intercept, right? So to solve this kind of question, your understanding about the straight line equation, what is the meaning of every term into this equation, and which values of the straight line equation is compatible to which values of the line waiver, but equation is really right. Now, keeping all things into your mind, now we can say that you need to define, derive the value of k, right? You need to derive the value of the k. So basically, by looking at this, what we can say that, I'm going to the next slide, we can see that km upon Vmax is equal to m, right? And m means slope, isn't it? I'm going back once again, look at this. Km upon Vmax is equal m, right? M. Okay. So basically, yes. Now, if I write here, now then you need to define the value of the Km value, right? So whatever thing you need to derive, you need to key that thing onto the left side of the equation and send everything attached to it onto the right side, right? So it will be basically equal to slope, right? Or basically m times Vmax, right? Right? Or basically, if I do this entire thing like this, not write it slope this time, and writing only m this time, and we will plug these values later, right? So it will be equal to m times Vmax. That's very much clear, right? Now, again, Km can be written like m is equal to the slope, right? And what is Vmax? If you look that here, 1 upon Vmax was a y-intercept, right? So basically, Vmax will be equal to 1 upon y-intercept. Is it me? Why I am doing these kind of changes? Because the option given in the question are not in the terms of m and c, they are in the terms of slope and y-intercept, right? So I think A will be the correct answer, and yes, A is the correct answer of this question. It was very much simple, right? So my advice to all of you is that whenever you are dealing with the equations, try to note down the equation, understand the meaning, and just do it, and you will be done.